All right, in this video lesson, we'll be discussing the unit circle. All right, so what is the unit circle? Unit circle is a circle on the Cartesian plane with its center at the origin and a radius of 1 unit. So let's see what that is. Again, a circle on the Cartesian plane. Well, there's our Cartesian plane, the xy axis. There's our circle. And the circle is being drawn with its center at the origin and the radius is exactly 1 unit. Well, if that's the case, then we can identify these these 4 points here. This point here, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So again, circle on the Cartesian plane. It centers the origin, and because the radius is 1 unit, and what that means is if we were measuring in feet, then the distance of this radius will be 1 foot. If the units was miles, the distance from the center outside or the radius would be 1 mile. So whatever the units is, the distance is exactly one of them. All right. And so what we have here is a blank unit circle. And so the unit circle, in order to fill in all of these different blanks, they're asking us to determine the degree measure of each angle, its radian measure, and the coordinates of each of these points. In order to do this, it relies upon some basic concepts. One, we're going to superimpose everything you know about special angles, 30, 45, 60, and 90, onto the unit circle. You also need to know your conversions, how to convert from degrees to radians, and finally, what you know about special right triangles, what you've been introduced to with Scholl. So here we go. We're going to start with filling in the degree area, the degree angle at each dashed line. And so what I'm going to do is not go sequentially, but use multiples of 30 first of all, and then I'll come back and deal with the 45s. So what I mean is this. Our first angle is 0 degrees. And so if I was to add 30 to that, I get 30, which means this next angle is 30 degrees. The next would actually be 45, but I'm going to skip that and come back around. So I'm going to first take care of all of the multiples of 30. So if I add 30 to that, I get 60. There's my 60-degree angle. Add 30 to that, there's my 90-degree angle. Add 30 to that, 120. There's the 120. Again, the next angle we're going to skip because that's the multiple of 45. So I add 30 to that, 150. So that one's 150 degrees. Add 30, there's my 180 degrees. Add 30 to that, 210 degrees. Add 30, again I'm about to skip. Add 30, gives me 240. Add 30 to that, 270 degrees. Add another 30, 300. About to skip. Add 30, gives me 330. And add 30 more to give me the 360. So now that I've got all of my multiples of 30 filled in, I will now come back and deal with the missing 45s, or multiples thereof. So my first one, there's my 45-degree angle. If I add 45 to that, it'll give me 90. 90 is already identified. Add 45, 135. So there's that missing multiple of 45. Add another 45, 180. It's already there. Add another 45, 225. Add another 45, 270. It's already there. And add my last 45, 315. Fits it in. And if I add one more 45, it's the 360, which we already have. So we now completed filling in all of the degree amounts on our unit circle. Now it's time to deal with the radian part. So in order to fill in the radian, we're simply just going to convert each of our degrees to radians. So if you recall the way we do that, we simply take our degrees and multiply by pi over 180. Again, pi over 180 actually has a value of 1 because pi radians is the exact same thing as 180 degrees. Or we can simply take degrees, divide by 180. In essence, in the calculator, it's recommended to simply put degrees over 180. And this is what I mean. If we go to our calculator and we simply use the fraction bar. So for 0 degrees, 0 over 180. And that'll give us our radians, 0 pi radians. Next was 30 degrees, 30 over 180. And I'm emphasizing the over because if we put it over, the calculator will output the value as a fraction. In this case, pi over 6. If I would have done division, 45 divided by 180. It gives us one extra step we'll have to do because the calculator is going to give it to us as a decimal. If I convert it to a fraction, there's the pi over 4. If I had put it in as a fraction in the first place, calculator would have output as a fraction, pi over 4. So if we go back to our PowerPoint, our different radians will start off with 0 pi, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, etc., etc. So all of my purple values we got by simply taking our degrees, converting it to radians. Now I'll make a point about my 0 pi. I could have either put 0. I'm emphasizing 0 pi to overemphasize that this is radians as opposed to degrees. So that's purely for emphasis. All right. All we got left is our ordered pairs. So in order to do our ordered pairs, we're going to look at our very first angle first. So I'm taking my 30-degree angle, and what I'm going to do is utilize everything I know about special right triangles. In order to apply special right triangles, I first need a triangle. So I'm going to imagine drawing a vertical line. And what this will help to do is to identify the triangle. More specifically, a 30, 60, 90. So in our 30, 60, 90 triangle, let's identify our sides. So horizontally, we'll call it X. Vertically, we'll call it Y. And our hypotenuse here was actually the radius of our circle. So we know the hypotenuse actually equals 1. Again, because we're working with the unit circle, our radius is exactly 1 unit. Each of these green and blue lines all act as radii for the circle. But as soon as I superimpose this triangle here, what was a radius to the circle is now the hypotenuse of our right triangle. So we'll go ahead and use Schul to help us determine the x and the y, which will give us our ordered pair. So SHL, 1, 2, radical 3. Our short just happens to be the y, long happens to be the x. And of course, the hypotenuse is 1. So y1x. We have our ratios. That'll help us to solve our y. So there we go, 1 over y, 2 over 1. Cross multiply, solve for y is 1/2. So we got half our answer. Now let's use the second half of it to find our x. Set up the proportion, cross multiply, divide by 2. There's our x coordinate. So now for this point right there, we have the coordinates of radical 3 over 2, 1/2. The x was radical 3 over 2, the y was 1/2. Now that we have the ordered pair for this point, we can transpose it to all similar places. This is what I mean. This point right here is the exact same distance from our origin as this point. So because it's in quadrant 2, our coordinates will be negative, positive. Again, the x distance, the horizontal distance, is still a distance of radical 3 over 2. So with that being said, this point right here, same coordinates, just got to alter the signs. Over here, this point, same coordinates, just have to alter the signs to match our coordinates. So we're close to being finished. So now, let's take our attention Not to the 45 yet, but I'm going to go all the way to the 60. I'm going to draw my vertical line to help me visualize my right triangle. And again, I have another special 30, 60, 90. So horizontally, it's my x and my y, vertically. And of course, my hypotenuse is still 1. The difference here is now my x is no longer the long, it's now the short. So when I do SHL, SHL, 1, 2, radical 3, under the S will be the x, and under the L will be the y. So let's go ahead and use this portion of the proportion to solve for x. Cross multiply, divide by 2, x is 1/2. Use this portion of the proportion to help us solve for y. Cross multiply, divide by 2, there's our y. First thing you notice, the values are the exact same as what we came up with for the 30-degree angle. And it should be sensible because it's also still the same 30, 60, 90 triangle. So that means the coordinates for this point are 1/2 radical 3 over 2, which is the exact same coordinates, but just reversed. Because what was the long for the 30 is now the short, which means what was the x coordinate for the 30 is now the y coordinate for the 60. So we'll go around the circle and transpose those values. So the coordinate for that point right there, same coordinates, different signs. So this point right here, the coordinates are negative, negative, and the coordinates for that point, positive, negative. So all we got left is the 45-degree angle. So there's our 45. I'll project my dotted line to see my triangle. Here we've got our x and our y. But of course, because of a 45, 45, 90, the x and the y are the exact same value. My hypotenuse is still going to be 1. So now when I use SHL, I'm only using 1 radical 2. We'll go ahead and solve for the x. So I'll put the x under the 1, under the s, and the 1 under the h. Let's go ahead and solve this proportion. Cross multiply, divide by radical 2. Simplify this by rationalizing the denominator, gets us at radical 2 over 2. So if x is radical 2 over 2, y is also radical 2 over 2. So the coordinates for this point, radical 2 over 2, radical 2 over 2. Now let's superimpose them all the way around the circle. So this point right here would be negative, positive, same coordinates. Coordinates here at this point, negative, negative, because of quadrant 3. And in this point right here, positive, negative. So now we've got all the values completed. So this is what our unit circle looks like, totally complete. Recalling that what we have in green and blue was pretty straightforward. We were simply adding by 30s, adding by 45s. Everything in purple we got by simply dividing everything by 180. Everything in red, we did a lot of work using SHL to get these different values. So if you look at all the red, it could look a little overwhelming, just as they are in red. But if I did this and changed my colors some, now I don't just have red. I have red, blue, and black. Let's first notice all my black. Every single value has a denominator of 2. Everyone. Now let's look at the red. If you go around the red, which is our y coordinates, they all have a pattern. 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. And our blues, the exact same but backwards. 3, 2, 1, 1, 2, 3. 3, 2, 1, 1, 2, 3. And the last thing is to acknowledge that every single one of these values, 1, 2, radical 2, and radical 3, were all the values from SHL. So again, this is the unit circle. It will be used for a very long time throughout the rest of the pre-calculus course. So it will be used as a resource, and you need to be extremely familiar with it. So hopefully this helps.